belter. It's incredibly beautiful. Now, question 7, page 334. Cosral yet again. Now, Bob and Alice are walking along a straight path AB. So there they go, doink. Oh dear. At point B, the path is diverted around a lake. So I can go this way, that way, and carry on going straight. Or I can go this way, hit F, hit C, and carry on. Or we can just swim across. I don't think that's an option. They choose path B, E, C, or path B, F, C. And then we're told all these lengths and angles, and that's been fully done for us and labelled, so we're happy with that. And the question is this: which is the shorter route, BEC or BFC? Sounds ever so easy, doesn't it? Well, it is. It's just very, very, very long. Now look, this is a straight path going across the middle like so. I want to work out the length BF and the length FC and compare the total length BFC with the length BEC and see which is the shorter path. Now what have I got? I've got a length here and a length here and an angle, and I can work out the length B to C using the cosine rule. I can do that, that's for sure. I can also write in a couple of angles which I may or may not need. I know this is going to be 35 degrees because I'm on a straight line straight through, and I know this is going to be what's that going to be, 50 degrees. So I've got a 35 and a 50, and I know this angle as well because 35 and 50 is 85, and that leaves me with 95 right there, doesn't it? So I've got 3 angles inside there as well. So there's 2 things I can do. I can work out this length here from B to C using the 80 and the 240 degrees and the 70, or can I work out another way? I think I'll use what I've been given here. I'll use the 80, the 124 and the 70, and then just calculate that length there to begin with. If I know that length there, I know the angle opposite that length is 95, then I can begin to apply my sine rule to work out the length BF using 50, and use my sine rule again to work out the length CF using the 35. So having spoken out what I see there, I need to use the cos rule once to get B to C, and then I need to work out, use my sine rule to work out BF and CF, and then compare them with length BEC. Alright, so that's what I'm going to do in all probability. How are we doing? Just scanning back over the other stuff here. Yeah, I can do that. Right, let's just do this. Let's just do angle BC. Length BC rather. So length BC is the one that we want. So we can say here, let's just work in black. So BC is, if you like, the length, the leading length. So BC squared equals the other 2 squared. So 80 squared plus 70 squared minus 2 lots of the other 2. In other words, 80 times 70 multiplied by the cosine of the angle that's opposite the side BC. In other words, cosine of the angle 124. Let's just work it out in one step. We've got 80 squared plus 70 squared. Where's the square button gone? Minus 2 bracket 80 bracket 70 multiplied by the cosine of 124, and that gives us 17.56. Sorry, oh, misread that. It's 17,562.96. Okay then, it would be, because these can be quite long, aren't they? Therefore, BC is going to be the square root of 17,562.96. Just fit it over there now. Root it. Yeah, that's more like it. That gives us 132.525 meters. Yeah, because this is an obtuse angle. That's 80, that's 70. That's going to be bigger than either 80 or 70, and there it is, 132.52. I will now write it in and make use of it. 132.525 5 meters. Alright, so now what I can do is I can use this length, the 132.525, with that angle there, and I can use, just change colour, this 50 with the opposite side BF, and to do a sine rule setup thing. So let's just do it then. What I want I put on top, so I want length BF, so BF divided by the sine of his angle, so to speak, sine 50, is just like comparing the length of 132.525 divided by the sine of his angle, which is sine 95. Then you just take the sine 50 over and multiply. So BF is going to be 132.525 divide sine 95 multiplied by sine 50. I'm going to have to change to yellow because it's all getting very invisible. So here we go. Listen to me speak it then. 132.525 divided by the sine of 95, that's his sine, and multiplied by the sine of 50. And that gives us 101.9 meters. So that part is 101.9 meters. Just label it in 101.9. Now I'm going to do the same with the 35 degrees and the length FC. I'll work down here in yellow. So FC divided by his angle, which is sine 35, well, divided by the sine of his angle. That's just like saying 132, do it carefully, 132.525 divided by the sine of his angle, which is of course sine 95. So similar to this setup here, obviously, take the sine 35 over and multiply. So FC is going to be 132.525 over sine 95 multiplied by sine 35. We'll get an answer now underneath here. So 132.525 divided by sine 95, and then multiply that by the sine of 35. Yeah. Bam, what we got there? I have got 76.3, oh that'll do, 0503, so that's correct. So 76.303, leave it alone, and that's meters. So what have we got all together? Let's just do a compare and contrast then. We go BEC equals 80 plus 70, which is 150 meters. We've got BFC equals, well, beta F is 101.9 plus F to C, which I should write in blue anyway, so it's all consistent. Now back to black. So 101.9 plus 76.3, that's going to give us, let's use a calculator, I'm a chicken, 101.9 plus 76.3. We've got to do this carefully to draw a conclusion. 178.2 meters. So let's just take a look then. Which is shorter, route BEC or route BFC? Conclusion, therefore BEC is shorter. And we can say it's shorter by, let's do a quick subtraction there, 28.2 meters, just to make it absolutely black and white. Well, black, yellow, blue, red and white. So there we go. That's a really lovely question. Very, very deep, very nice. I will stop there. And the next bits we do are really, 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 really easy. So I look forward to doing that because I don't have to think too much about it. In the meantime, you've got to think about this one. Bye bye.